Hello everyone. We want to fit a machine learning model which we call support vector machine to a training data set. The training data set is the iris data set. It is one of the most famous data sets in data science community. So this data set consists of three flower species: Setosa, Versicolor and Virginica, and all of these are classified based on four features, and these four features are sepal length, sepal width, petal length and petal width, and all these data are measured in centimeters. So there are 150 total data points and 50 from each class or from each species. So this is what the iris data set looks like in pandas data frame. So this column is the values for the sepal length, this column the values for sepal width, petal length, petal width, and the last column indicates the species to which each feature vector belongs to. Suppose this feature vector belongs to class 0, so 0 means Setosa, and there are species which are indicated by ones, so there are ones here, and 1 means it is Versicolor, and 2 is Virginica. So I exported these, I imported these pictures from Google: Setosa, Versicolor and Virginica. So my goal is to train a support vector machine to this training data set, as well as to visualize, to see in graphs what is going on behind this model. So since the feature vector consists of 4-dimensional data points, right, and then it's difficult to visualize, so what I want to do here is we take only two features, petal length and petal width. Okay, and also we want to take only two species, Setosa and Versicolor. So we do not take Virginica, because to make it simple and easy, since a support vector machine is basically a binary classification, so we consider only two classes. Okay, so the training data consists of two classes and two features, petal length and petal width, and then there are 100 data points. So if we plot these data points in 2 dimensions, here is what they look like. So there are 2 clusters. So this cluster belongs to a Versicolor. The another group belongs to Setosa. Okay, so there are 2 distinct classes, and here blue species 0, so 0 means Setosa, and orange, which is 1, that means it's a Versicolor. Okay, so now we want to train the support vector machine. So what is the intuitive idea behind this model? So all we want to do is to train, so we want to train a model SVM to this data set. So training a data set or fitting a data set to a model means, in this case, in this support vector machine model, we want to find these weights. W1 and W2, and B, which we call bias or coefficient. Sorry, B is called intercepts. W1 and W2 are called coefficients. And once we get these three values, then we can make a decision function which is given by this. Okay, so f is a function w1 times x1 plus w times x2 plus b. So here x1 is the petal length and x2 is the petal width. So training a support vector machine model, we can obtain the values for w1, w2 and b. So how do we find these values? Okay, so there is a lot of math behind this theory, or basically we set up an optimization problem, and it consists of a lot of linear algebra and calculus, and I do not want to cover that in this video. So the only thing we want to do here is so there are three lines. The middle one is called decision boundary. So this line is called decision boundary. Okay, and there are two other lines. So fitting the data means fitting the data to the model means we want this, which we call the margin. So we want this margin as big as possible, so that no data points is in between these two lines. Okay, so all the orange data points are on this side, while the blue data points are on the other side. So none of these data points is in this strip, and so based on this, all we need is finding these values, the values for w1, w2 and b. So fitting the data means we get these three values. Okay, and how to fit the data? We fit the data so that this margin is as wide as possible. Okay, so that none of these data points are between these two lines. Okay, so once we fit the data to the model, that means we have the value of w1, w2 and b. Then we can have this decision function. Okay, and then we can make a prediction for new data set. Suppose if you have a new data set, this one, so it means y1 is the length, petal length, and y2 is the petal width. So fit this y value into x1 and y2 into x2, and then see if the sign of this is positive or greater than 0 or less than 0. The value of function is positive or negative on this new data set. If it is negative, then the new data set belongs to Setosa. If the value is positive, bigger than 0, then the data set belongs to Versicolor. Okay, so I want to see how we got those, how we can fit the model, and then once we fit the model, how can we get the values of w1, w2 and b. So let's do that in Jupyter Notebook. So the first one is just import libraries. The second one is importing data set, the iris data set. So this one is just the data set. So this is the full data set, but we want only petal length and petal width and only 2 species. So this is what we call slicing. And then now the new data set looks like this one, and this is the one we want to train the model. And then this one is fitting the model or training the model there. So now the model is trained, and then we want to make a prediction, right? If you want to make a prediction on this new data set, just hit CLF is the model dot predict. So the output is 0, so 0 means Setosa. If you want to predict another data, another new data, this one, so 4.5 is the petal length and 2 centimeter is the petal width. So which flower species this belongs to? So let's see. So 1. So 1 means it's a versicolor. Okay. So now all we want to do is what do we mean by training the model, right? As I already told you that training the model means finding the values of W1, W2 and B. So this is how we can get these values, W1, W2. So equals CLF dot cof means coefficient underscore. Okay, so this is a numpy array, so I need double brackets, and B is called intercept, so CLF dot intercept underscore. And you want to check what the W1 is, so it's a 1.1, W2 is 0.7 and B is negative 3.27. okay, so once we get this W1, W2 and the value of B, we can sketch the graph of the decision boundary. Okay, this is what I have done here. So this line here, the blue line, is the decision boundary, and this is the equation of the line. So W1 x1 plus W2 x2 plus B equals 0, which we call decision boundary. Okay, so to sketch the graph of this decision boundary, let me go back to this file here. So decision boundary is right over here. So this is the equation. So now we plug in values for W1, W2 and B, we get this equation. This is the equation in 2 variables, x1 and this is supposed to be x2, okay, not W2. So there is a typo. So to sketch this line, we want to solve for x2, right? That's why we solve for x2, and then this is the final expression for x2. So now you can plot this, which is actually this line here. This is the decision boundary. Okay, and so along x-axis you have a petal length, which is x1, and along vertical axis, which is PW, petal width, in this case is x2. Okay, so now we want to actually make a prediction by hand, by manual calculation, right? Because we have the decision function. So the decision function f of x is which is right over here. This is the decision function here. So 1.1 times x1 plus 0.7 x2 and minus 3.27999. So 1.1 times x1 plus 0.7 times x2 minus 3.27999. So now to make the prediction, all we need is just plug this 1.5 for x1 petal length, and this is the x2 petal width. So 1.1 times 1.5 for x1 plus 0.7 times x2, so plug 0.5, and minus 3.279. And if you type in a calculator, the value you can get is minus 1.27999. So it does not matter what the value is, all we care is the sign. So it's a negative sign. So negative sign means this data set belongs to Setosa. Okay. We do the same thing for another data set with petal length 4.5 and petal width 2 centimeter, which is x2. So the value of the decision function, so 1.1 times x1 is 4.5 plus 0.7 times x2 2 minus 3.27999. So if you type that in a calculator, you can get 3.07001. Okay, whatever the value is, it's always gonna be a positive number, so it's bigger than 0. So positive means it belongs to Versicolor. Okay. Because in the data set right here, all the data points which are on this side of the line, the value of the decision function is positive, and on this side of this line, the value of the function is negative. Okay, less than 0 and greater than 0. So all it matters is the sign of this decision function for the new data set. Okay, so what I want to prove on this video is that so training a model or fitting a data to a support vector machine model is just computing the values of W1, W2 and B, so that we can get this decision function. So we can get this decision function, and to make prediction for the new data, all we have to do is plug in the values for this new data here, and then if the value is positive, it belongs to Versicolor. If the value is negative, it belongs to Setosa. Okay, so that's all in this video. Thank you for watching.